Can you see? Okay, so you can read this whenever you guys want a chance. It's not a big deal. All it's saying is how that vectors have direction and magnitude. And then it says, example, let's draw some arrows for fun. I mean, I don't know how much fun you can have drawing arrows, but I guess let's just try it. So here's an arrow, and I mean, I guess I'm having fun because I'm interacting with my tablet here, and my tablet has little arrows. And usually you want to label your arrow with something. So I label it by saying A, and you put a little hat on it. So, you know, there it is. A has a hat, and sometimes you'll hear professors going a hat, and it just means that. If you do this, A with a arrowhead like that, that is fine. It's the same thing, but this is what I think most math professors and physics professors are used to. And yeah, and there it is. And if you call that A, then going in the opposite direction has to be A minus. Of course, I'm trying to make the same magnitude here, but that would be a negative A there. That's fine, miss. You're good. But yeah, that would be negative A there like that. Does that make sense, guys? Okay, so hopefully all this is review, I hope. And if it isn't, no big deal. So now we're going to go ahead and start plotting vectors and relax. Don't have a heart attack or anything. Anytime you see this 3i and 4j, that 3i means in the x direction. In the x direction. And that 4j means in the y direction. In the y direction. And if we had another one called k, then that would be in the z direction. So there it is. So how do I show this vector? Well, if you want to start from the origin at 0, 0, then you can just go 3 units to the right and 4 units up. 1, 2, 3, 1, 2, 3, 4, put a point. Put the tail at the origin and put the arrowhead at the ending at the 3, 4. Boom, there it is. I'm going to call that vector A. This is also called the resultant. Also called, well, you know what? I'm getting ahead of myself. Let's add A and B, and then we'll call that the resultant. So there it is. That's vector A. And another way to write a vector is to use these deals, and that is called a chevron. Hence the gas station chevron. You notice that Chevron gas station has these. These are called chevrons. So that's called a chevron, guys. This is the x component. This is called the y component. Yes, I am going to be posting this. Sorry if I am lagging. Am I lagging extreme? Okay. Yeah, I'm sorry, guys. I'll post all this, and I'll see if I can slow down a little bit, because I do realize once I'm warmed up, I just go like super fast everywhere. So I'm going to try to make myself cold. Okay. I thought it was funny, but it's not funny. All right, guys. So here we go. I have another vector, a vector B, and I'm going to go ahead and write this one in blue. So vector B, I got to have a little arrow. I didn't notice that I didn't put an arrow there. So that's my vector B. And it says 3i plus 2j. Oh, let me go back to blue. So I do my little chevron. That's not blue. What's wrong with me today? Blue, 3, 2. So if I start from the origin, let's see, 3, 2, point. So here's my vector B. There it is. And that's vector B, guys. And then I guess I should have put a letter on this, no big deal. Find the sum of A plus B. Well, when you add vectors, you add them tail to head, or head to tail to head, or head to tail, I guess is what I should be saying, right? So if I take vector B, this blue one, and I add it to this A one, so let me see if I can copy here, duplicate. No, I don't want to duplicate that. I want to duplicate the arrow. Duplicate, there we go. Let me see. Can I put it? Almost. Come on, buddy. It's kind of hard to get it perfect, guys. I'm trying to. But it doesn't show me. There we go. Oh, it's almost perfect. So there it is. That is A plus B. And this is called the resultant vector. from the origin all the way to this point right there. And I don't have a black arrow, so I'm going to draw this one. That arrow right there is A plus B. That's also called the resultant. Because result, quote unquote. Now, okay, I'm going to slow down, guys. You can always add component by component, and this is not anything extreme. 3, 4, well, that was vector A. Vector B was 3 and 2, so I'm going to write plus 3, 2. And notice you can just add the x's. Add. And then you can add the y's. Add. So what do I got, or what do I get? 3 plus 3 is 6. 4 plus 2 is also 6. So notice that my resultant vector terminates at 6, 6. Yep, it does. 6, 6. Perfect. Everything is beautiful. Everything makes sense. How do we feel so far, guys? Awesome. Jacobs, you feel all right? This is too easy for you? It's too easy, I think. Mr. Wentz has probably already taught you guys all about vectors, and you guys probably don't need any more of this because you guys are already professionals. And I agree. I think most of y'all, already figured these out. They're not too bad. So this one says, what if we have multiple vectors? And I have a whole bunch of them, A, B, C, D, and we're just trying to add them. So I'm just going to put them here on the side. Vector A is 3, 4. Vector B is -2, 4. Vector C is 3, 2. And vector D is 1, -1. And it tells me find the sum of all 4 vectors numerically and then find it graphically. All right, no big deal. Let's add them all up, guys. 3 plus a -2, that's 1. 1 plus 3, that's 4. 4 plus 1, that's 5. So it looks like 5, 4 plus 4, that's 8. Plus 2, that's 10. Minus 1, that's 9. So there it is. All of them added together give me 5, 9. Make sure to use the chevron. So catch up to there. If it's okay with you guys, I'm going to use all one color here instead of writing A, B, C, D. So here we go. Vector A is 3, 4. So I'm going to start at the origin and I'm going to go to 3, 4. So 1, 2, 3, 1, 2, 3, 4, point. So this is vector A. And then I'm going to go from vector A and I'm going to add vector B. Vector B is -2, 4. So where the vector A terminates, go 2 to the left and 4 up. So 2 to the left, 1, 2, 4 up, 1, 2, 3, 4. Put a point and then connect them head to tail. There it is. That is vector B. All right, now I'm going to go to vector C. So start at 1, 8. Am I going too fast, guys? Okay, continue at 1, 8. So at 1, 8, vector C, go 3 to the right and 2 up. So from the point 1, 8, I'm going to go 3 to the right, 1, 2, 3, 2 up, 1, 2. You should be at point 4, 10. And then connect them again, head to tail, put a tail on 1, 8, the head or the arrowhead at 4, 10. That is vector C. And then finally, vector D, 1 to the right, 1 down, 1 to the right, 1 down. So this little guy right here is vector D. And notice, I want you guys to notice, does that terminate at 5, 9? Yay, it does, guys. It terminates at 5, 9. So I'm going to go ahead and start from the origin and connect it to the arrowhead at D. So this is called what? The resultant. It really doesn't matter how you add the vectors. You can add them all over the place. When you do the delta, when you do the delta, some of you guys have started calling it delta and it's rubbed off on me. Whenever you do the delta, You can drag these vectors all over the place as long as you add them wherever the arrowhead stops at the other, and it doesn't matter how you add them. You can add A, B, C, D, or you can add D, C, B, A. It doesn't matter. And the reason why it doesn't matter, because it's the same thing with like numbers. 2 plus 3 is the same as 3 plus 2. So it doesn't matter how you arrange them. Now, it is easier if you have a mouse. So if you have a mouse, it's easier to drag the vectors over just doing it on a laptop with a little pad. But whatever, you'll see what I mean when we start doing the delta. All right, guys, let's go to the next one. It says, all right, let vector A have an initial point. So this is a point. It has a point at 2, -5. So I go to 2, -5. Excuse me. And a terminal point at -2, -8. So that just means that it terminates there. So go to -2, -8 and put a point, -2, -8. All right, so you already know what I'm going to do. I'm going to connect one to the other. Start at 2, -5 and connect that one to -2, -8. There it is. It's connected. And they want to know, determine the components of vector A. All right, if you want, you can do a triangle, guys. You don't have to, but if it helps you. There's my triangle. Let's see, let's start here at this one. How many times did I move to the left? 1, 2, 3, 4. And I guess to be technical, I should put arrows there. I move 4 to the left, so that's -4. So here's vector A. Vector A is -4, comma. How many times did I go down? 1, 2, 3. And to be technical, put an arrow like that. -3. And there it is, guys. -4, -3 is my vector. Determine is the vector components, sorry. And then it says also find the exact value of this. All right, what that means magnitude. To find the magnitude of the vector. So how do you find the magnitude of the vector? Like this, guys. Double lines, put the little arrows, equals square root. And you're just gonna go -4 squared plus -3 squared. So what is that? Let's see, 16 plus 9. And no, you don't have to do all this work. I know that a lot of you already see it and you're like, oh, that's just a 3, 4, 5 triangle. Yeah, if you see it immediately, you can just write, it's 5. And that's it. It really is that simple, guys. What'd you guys think? Not bad, right? Happy face?
I have a question.
Oh yeah, ask.
So like, you know how you went horizontal then down? Why can't you go like down then?
You can. You could have written, you could have done this one in green. Just make sure that you keep the components, like going down is a vector for your y direction, and then going left and right is a vector for your x direction. But yeah, you could have done this one in green.
Okay.
Cool.
Thank you.
Good question, miss.
So what is the exact value of is it asking for the hypotenuse?
Yeah, it's just asking for the hypotenuse. That's called the magnitude. Why do they call it a magnitude, guys? That's connected to your physics. If I told you that my velocity in the x direction was 4 and the velocity in the y direction was 3 or -3, and someone were to ask you what's the speed of this particle, this is what you would do to get the speed. Is that what you did in physics? Uh-oh. Do I need to have a chat with Wince? Did you guys do two-dimensional motion? Yeah, whenever you guys were finding speed, did you have to do square root of your speed in the x direction squared plus the speed in the y direction squared? Okay, perfect. Yeah, it's the same. It's the same as this, guys. Let me see the chat here. Sorry, I didn't get to see it. Yeah, it's the same. So hopefully we'll all connect. We'll get more advanced as we start doing more and more vectors. And this is supposed to be you guys. I always have fun like trying to mimic you guys or talk. Okay, let's see. All right, so this is supposed to be you guys here. All right, Chavez, but what about multiplying a vector by some scalar? Okay, I know you guys don't have a voice that high, so I apologize, guys. Hopefully I didn't offend anyone. So all you got to do, guys, is just, I mean, what does it mean in terms of this graph? I guess it just means that you're just multiplying vector A by 3. If vector A goes all the way to negative 2, 1, just do 3 of those. So start at the origin, negative 2, 1. There's one of them. And then another one, go negative 2, 1 again. So here's another. And then go another negative 2, 1. And here's another. And if you put them all together, that would be negative 3a. Or sorry, that would be 3a. Let's see if we can verify that. Let's see if we can verify that this coordinate right here is, let's see what that is, negative 6, 3. All right, well, vector A is negative 2, 1. I guess I don't have to rewrite that again. So here's 3a. I'm just going to go ahead and go 3 times negative 2, comma 1. And then you can just distribute the 3 to both the x and the y components. Negative 6, comma 3. And sure enough, yep, that is at negative 6, comma 3. So it works, guys. Everything made sense there. All right. This is you guys again. Let's see if I can chat normal here. Try this. I was looking at the online questions, and they were asking for a component form, followed by magnitude, and then following the direction of my vector. Help! Okay. You should see the, I'm sorry, Ms. Harris. Ms. Harris is just looking at me like, stop, just do this question. All right, I'll do the question, Ms. Harris. All right, guys, so all we're doing here, we're gonna answer all 3 of those questions that they want. It says, let the vector V have an initial point of 6, negative 3. So start at that point. Start at 6, negative 3, put a point there, guys. 6, negative 3, 1, 2, 3, there's my point. And it says on a terminal at 2, 1. So that means it terminates there. So go to 2, 1, put a point. Here is my vector. No, I didn't like how I didn't start it perfectly. Let me rewrite it because it's not right at that coordinate. All right, here we go. Oh, that's good enough. So there it is. I don't see any mistakes there. So let's see, vector V. Let's see what that is. I went to the left 1, 2, 3, 4 times. So that's going to be a negative 4. And then I went up 1, 2, 3, 4 times. So 4. So I've answered my vector. I plotted the vector and I found the component form. So I've done that. Now I want the magnitude of that vector. So that's easy to do. Let's see if we can do this by hand here. So the magnitude of that vector is the square root of negative 4 squared plus 4 squared. And, you know, that's pretty simple, guys. I don't think you guys need a calculator for that. I mean, I guess you can, but you don't need it. 4 squared is 16. Another 4 squared is another 16. And then 16 plus 16, that's 32. And I'll slow down so you guys can catch up. And I know that I can break this down to 16 times 2. And no, I'm not making fun of anyone. I see that there's 2 of them right here, 2 16. So 16 times 2 gives me the 32. And then I know what the square root of 16 is. That's just 4. So 4 square root of 2 is the answer that I would prefer. I think that's the answer that that's the answer that Delta wants. Yeah, the seniors, I think the seniors call it delta, and now I'm saying it. Now they got me saying that. All right, next, the last, the direction of vector V. So it's always with respect to the horizontal, guys. So here's where your precal comes in. And I'm sure you've done this in physics. So here's my horizontal. They want this angle. That's the angle they want. If you don't see it, you can always make a right triangle right here. Let me do the right triangle in green. There's my right triangle. You could always find that reference. This is negative 4. This is 4. I'm going to slow down, guys. Hopefully you have enough experience that you can just look at it and say that your reference angle is 45 degrees. Relax. If you don't see it immediately and you want to know that reference angle, remember what you can always do? You can always do arctan and then just turn everything into positive, right? 4 over 4. The calculator is going to spit out 45 degrees. Though that's not the answer we want, though. That's 45 degrees. The one we want is that black theta. So since we want that black theta, all you got to do is go 180 minus 45. And there's so many ways to do it. This is not the only way, guys. Yeah. So there it is. The direction is 135. Direction of vector. Did all that make sense, guys?
Why does it matter?
Why does what matter? Sorry.
What way is it used for?
Well, it just wants to know like the direction. Why is it used for? Let's say we have a particle and this is the x and y component of the velocity. They go, well, what direction did it take off in? Well, if your x component velocity was -4 and your y component velocity was +4, the particle took off in a direction of 135 degrees. Do we have any questions on this, guys?